Hi, in this video we're going to use the area of a trapezium to find an unknown angle in that trapezium. So we're given that the area of this trapezium is 103.5 and we want to try and work out this angle x. Now we're dealing with trigonometry here. Trigonometry involves right angle triangles, but there's not a right angle triangle here. But if we add a length like this going vertically, we can see now on this left we do have a right angle triangle, right? Now, if we wanted to find x, we could find this angle here, say, and then add 90 degrees. But we need to use this area first to kind of find some more lengths, because in this triangle at the moment, we don't have enough information to be able to work out this angle. We know, for example, this whole length is 15, and if this length is 8, this is also 8. So this is 8. This must be 7 to make it up to 15. So that's 7, that's good. But we would also like to know this length as well, say, because if we know these two lengths, we can find that angle, and that angle plus that 90-degree angle will be the x, right? Okay, so how do we use this area here to find, say, that length? Now, let's remind ourselves of the area formula for a trapezium. The area of a trapezium is the average of the parallel sides, so A and B are the lengths of the parallel sides, multiplied by the height between them. Now, where are the parallel sides? The parallel sides here are this and this, the 15 and the 8, and the height between them is this, the h. So let's just label these. That's the height between them, the h, and these are the A and the B, the parallel sides. So let's just substitute into the formula. The area, which we said was 103.5, is equal to a plus b over 2, so 15 plus 8 over 2, multiplied by the height, which we don't know, right? Okay, so let's just simplify. That's 103.5 is equal to 15 plus 8 divided by 2 is 11.5, times by h, I can just put h like that. And then if I just divide both sides by 11.5, we've got h is equal to 103.5 divided by 11.5, and let's see what that is. It's exactly 9, that's great. So we know that this length here is 9, and therefore this length is 9, because we can clearly see that this length is the same as this length, because they're opposite sides of this rectangle, right? Okay, brilliant. Now, let's just say that we want to find this angle here, theta, because we know that if we've got the theta here, this angle, then we can add this 90-degree angle here in this rectangle to get the total angle x. So I'm going to draw this triangle out separately. And we've got the 7 and the 9 here, and we call the angle inside theta. So this is our purple triangle up here. Right, okay. Now, let's label the sides relative to this angle of interest. So this side here is opposite that angle, so that's the opposite. I'm going to put an O in a circle. And this side here is adjacent to, next to that angle, which is the A. And then let's use SOHCAHTOA. So SOHCAHTOA, that allows you to decide which trigonometric ratio to use. So we're using O and A. It's this one here, O and A. So we're going to use this one here. Now that shortfall, which we've seen in previous videos, tan of theta, T is short for tan, is equal to O over A. So now we just need to substitute into this formula. Tan of the angle, theta, is equal to O, which in our diagram is 7, over A, which is 9. And then we want to try and find out theta. To get rid of the tan in front of the theta, we do inverse tan of both sides. We write it as tan to the -1, like that. And the inverse tan gets rid of that tan on the left, leaving just theta. And we still will do inverse tan of the right-hand side, which is 7/9. So we do shift tan on your calculator to do inverse tan. Your calculator might work differently. And we get 37.9 degrees. So therefore, this angle here, if I just rub this out, that angle is 37.9 degrees. But we can see that this is a right angle here. So this total angle x is the 37.9 plus the 90, right? And that gives you theta, the x. So x is the 37.9 plus 90 and that is equal to the final answer of 127.9 degrees, and that's the answer, 127.9 degrees to 1 decimal place, and we're done.